Hey there, everyone. My name is Ryan Schul. Welcome to my channel. Thanks for tuning in today and welcome back. If you've been here before, welcome back again. So, today I want to talk about client churn prediction specifically for wealth managers. So, I've done a couple of videos about churn and how to analyze it and manage it and prevent it, right? When you have a client, it's always cheaper to keep that client than to go out and look for a new client, right? It's cheaper to retain the client than to go acquire a new one because you have to search around. You're going to waste a lot of time looking for new clients. So you want to keep what you have, right? Early identification enables targeted intervention. So if you anticipate that somebody might leave your business, whether it's wealth management or anything, any kind of service or product that you were selling, you want to keep that person coming back more and more and more, right? It's just easier for the business, more predictable, more sustainable, rather than just let them make one purchase and one transaction and then they take off and you never see them again. That's not what you want, right? You want to hold on to that client like a goose laying golden eggs, right? You want to take care of the goose, not necessarily the egg, because the goose is going to keep on laying golden eggs over and over and over. Once you, I don't know, sell the egg or something, that's gone. You have your money, but the transaction's done and it's gone. You want to take care of that goose. The goose is your client, right? And that goose is laying golden eggs, so take care of it. Automated profiling scales very effectively upwards and outwards, both, right? And we want to understand what drives client decision making, right? What really matters to clients? What's going to keep them engaged with our business, right? So things like that. That's what we try to understand and manage, right? So just to just for full disclosure here and a quick what's it called, preface or something. Let me preface this by saying that there's really no public data sets about wealth management because this is very secure information. It's very personal. You're not going to release the names and the incomes and the investment activities of your personal clients. That makes no sense whatsoever, right? So you're not going to find this data in the public domain. We have to create this to go ahead and illustrate the point of how to manage this whole process. So if you are a wealth manager, you have your own specific data that you can just plug into this model, into this process that I'm going to display here. Or if you have other clients, it doesn't have to be wealth management. That's what I understand. That's what I know. That's what I did for most of my career. So I know how this stuff works. If you have other clients that you're trying to retain as a dentist, I don't know what, a lawyer, even like who knows what, like a grocery retail seller or something like that, right? You can plug in your data and understand the methodologies here and understand how to take care of your clients better, how to keep them happy and keep them coming back. I'm just representing from a wealth management perspective how this could be done. So I'm going to go ahead and create the data because again, there is no public data set that we can go grab and download from Kaggle or whatever. Like it doesn't exist, right? This is all private and very confidential. So we know basically what the data will consist of. We'll have age, asset under management 90 days ago. This is how much money is being managed, number of transactions. So these are buy, sell transactions, right, for the client's portfolio. Number of meetings that we held with the client, last logins from the website or whatever. People are logging in to check on the account balances, right, or their portfolio values or whatever. Number of emails sent, emails replied, any kind of complaints filed within the last 90 days. So again, this is all specific to wealth management, but again, this could be transferred to or scaled up or out to any type of business. So here we want to try to create the or understand churn and the behavior of clients either staying with us, that's not churn, or churn is the client leaving, right? So we want to try to understand the number of asset change percent. If it's less than 0.05, we can consider this potentially churning, or this symbol right here represents an or, right? So if the number of assets under management is less than 5%, or the number of meetings in the last 90 days is 0, or the number of complaints filed in the last 90 days is 1, or the advisor changed in the last 6 months, one time, we can create this, or we can anticipate that can be a churn event, right? So low assets under management, low or no meetings, this is no meetings, number of complaints filed, 1 complaint, and you switch your investment advisor, that's probably a churn event, right? So if your business operates a little bit different, the criteria to define the churn event might be slightly different, but I think this makes sense in this scenario. And in your scenario, you would have to like customize this or modify this or massage this slightly to get a churn event. And you might have to define this variable if it's not given to you, and you might not have churn. You might have to anticipate what could create a churn activity or a churn event, right? That's what we're doing here. I wasn't given churn in the original data set. There is nothing that indicates whether a client will leave or stay with us, right? But based on these criteria, if any of these are true, because these are all or characters right here. If any of these are true, this or that or that or that, one of these four, then we can define that as a potential churn event. And I can't guarantee that the client will leave and actually churn or move away from the business, but most likely, if these scenarios are true, then the person's probably getting out, hightailing it out of there. So also, we can have the response rate, emails replied, divided by emails sent plus 1 to create like the one baseline, the denominator, right? We're dividing, the numerator is in the top, and the denominator is in the bottom. So the response rate of emails is something that we might want to keep an eye on as well. So, okay, so I just created the churn. So I'm going to create the churn event right now. Okay, that's what we define as churn. So I'm going to set my machine learning model right here. So I'm taking everything from the data frame, dropping the client ID, the advisor ID, and the churn event, because we're trying to predict churn. So as your independent variable, you'll never have the target variable or the dependent variable that you're trying to plot, right? You drop that, and the IDs are completely irrelevant. Like, we want to know the client ID, we want to know the advisor ID and the data, but that's not used to make a machine learning prediction, okay? You're not predicting IDs, you're predicting churn. So this is a dependent variable, and it's dependent on these independent variables over here. So let me go ahead and run this, Control Enter to run. So just take a quick look at this. If you don't understand machine learning, totally fine, totally acceptable. So I have several videos on my channel that you can check out to learn more about this. I'm not going to get into like real deep discussion about machine learning, but again, I have a lot of discussion on my channel about how this stuff works, and YouTube has a lot of rich videos, very rich ecosystem about machine learning, data science, artificial intelligence, deep learning, all these topics. You can find all this stuff on YouTube, very easy, or just do a quick Google search, okay? But this is the outcome. So we've already trained and tested the XGBoost model. That's what I'm using right here. So here's XGBoost classifier, okay? You have the train and the testing set, okay? And the test size is going to be 20%. The training size is going to be the opposite, so that's 80%. Okay, we do a random state of 42, so we start randomly and pick 80% of the population for testing. For training, 20% for testing, and then we make our predictions right here, right? So we set up the model, we fit the model, and we have the Y predictions and the probability of that. So you can see overall precision, 97.6%, pretty precise in terms of making predictions. F1 score pretty high. You want this to be close to 1, that should be close to 1. These should be close to 1. So the model overall is performing quite well, and it's doing a very excellent job of understanding historically what has caused churn, and we're able to pretty accurately predict churn at the rate of about 97 or 98%, right? So pretty accurate. So we want to take these figures and go ahead and create a churn probability. So the churn event can be binary. If you look closely here, we have churn. 0 is nothing, nothing's going to happen. 1 is an event. The person's going to leave the firm, right? So they're going to take the business elsewhere. They're leaving our wealth management, asset management, investment management business and going somewhere else, going to a competitor. We want to prevent that. So in this case, these are all zeros. These guys are not leaving. But it's kind of hard to say, well, they're not leaving or they're leaving. So it's 100% or 0%. I want to define that just a little bit better and try to understand what's the probability of that event happening. So it says 0 here. So is it actually really 0, or is it close to 0, or is it actually closer to maybe 0.49% that or probability that the person could leave? That's something that we want to be aware of, not just like zeros and ones. That's nice to know that, but I also want to know the probability of the person leaving, right? So that's what this step here is for. So we're looking at the trained and tested data set. Remember, the independent variables are the X variables. We're taking everything, putting that to a list. That becomes the feature column, and the model has been trained above. It's been fit and trained. If you look closely over here, you see the model XGB classifier. That comes from over here. If we trace that back, we're using a classification engine. Classifier goes down here. And we are looking at this model right here on the train set and the X train and the Y train. So again, the X is independent variables. These are all the variables that are not churn, advisor, or client ID. Remember, the IDs are useless. We're not trying to predict an ID. That makes no sense whatsoever. We're trying to predict churn, so we drop the churns, drop the IDs because it has no influence on predicting churn, and we try to predict the churn. So we take the, Y train from here and X train from here, fit the model, and then use that fit model that has been trained and tested to make predictions. So we're trying to create the churn prediction, or the churn probability, which we get over here. So this is 1, 1, 1. These guys are definitely leaving according to the very basic primitive data, or wait, let me see. Why is this thing not refreshing? Say it's time for a new computer, guys. Time for new computers. Always like giving me problems and struggles, and I have to do 10 times more work because this thing just doesn't perform. So anyways, the website disappears, or whatever, the Jupyter Notebook disappears. Let me refresh this. Of course, it's going to go slow too. So yeah, just distracting, very distracting. Okay, so back to here. This is what I want to show you. So here's the churn, right? So very basic, very primitive kind of setup here. But is this really machine learning? No, this is nothing. This is just basic logic that we came up with to try to determine what is a churn event, right? But I want to understand, like, what's the probability of this actually happening? Not is this going to churn or not churn, right? I want to understand like the details or the minutia or the granularity behind this, right? So the churn probability is actually 0.99. So this person's probably leaving 0.99, 0.99, 0.99, probably 0.99013, 0.99063. So probably leaving, but this 1% just says definite, right? So here we have just a more granular kind of perspective on things. And I'm only looking at these filters now. I'm looking at churn probability greater than 70%, right? So if you look in the original data set, we always have the rows and the columns. The rows were 1,000. So we have 1,000 client records, 13 columns or 13 headers or 13 features. Now down here, we're just looking at the percentage that has greater than 70% chance of turning. This is a churn probability greater than 7. And that's what we came up from our machine learning algorithm. Remember, these are the independent variables. So everything that is not an ID or churn, we can use to predict whether or not the person's going to leave. So age, number of assets under management 90 days ago, number of transactions, emails sent, emails received, emails replied, things like that. Advisor ID, we're dropping asset change percent. So that's gaining or losing money on the invested assets in the portfolio, asset under management latest, and then the churn event, right? So that's the X variable that we get down here, and we're taking everything and using all of these trained test features to make predictions about the churn probability. So that's what we have in the last column right here. So let me refresh this out. This is called a SHAP bar. And we can use this to determine what is the probability or what features contribute to churn the most, right? So which feature, if I told you advisor change in the last 180 days mostly contributes to a churn event, would you believe that? Does it make sense? You know what? I don't know. I have to look at the model and see what it's telling me. Assets under management 90 days ago, or the age of the client, or the number of meetings held, or emails sent, or emails replied to, or any of these events driving people away. That's what SHAP is for. So it tells you how the model is performing under the hood, right? And it really helps you to understand what is basically a black box for taking all this data, just dumping it into an X variable and training, testing the model, and making predictions. So how does all this stuff really work? The SHAP model, or the SHAP evaluation process here, helps you to determine that. So now we have churn probability. It says 60% of churn events are determined by churn probability. So that's what we just calculated over here. So I know that, like, these two are highly related, right? Or highly correlated. It's called a correlated event. These are highly correlated. So I can kind of ignore this one, right? But I can look at this down below and get better insight into what's really driving clients away. Logins in the last 90 days. So if there's fewer logins, fewer people are interacting with the wealth managers, and they're getting ready to leave. Probably they're just disengaged. They're not that interested in maintaining the relationship. Number of transactions, if this is down, this is probably driving, people are getting ready. They've already made up their mind. They're going to leave, right? Asset under management change percent. So if your portfolio is down, you might be getting ready to leave. Response rate, if the response is low, if people are sending you messages and you're not replying, maybe people are getting ready to leave, right? So all of these are drivers in creating churn. And we can see kind of the same effect over here. So churn probability, anything in blue is negative, anything in red is positive. Number of logins in the last 90 days, asset under management changing, response rate. So that kind of makes sense. Hopefully these things make sense. This is basically indicative, right? This is anticipating when a client is going to leave and to take their business elsewhere. Okay, so this chat model helps us understand what the XGBoost model is actually doing, right? So if we take a step back just quick, we have the classifier over here. This sets up the model. Here's the training for the X variables. Again, all the independent variables, the Y are the dependent variables. Here's the Y right here. Here's the X right here. So hopefully that makes sense. Taking the model, training, testing it, using the X variable right here to make predictions. And based on that model that's been trained and tested, we can calculate the churn probability. This is under the hood and behind the scenes how that model is working, right? So which features have the highest impact on driving clients away? Why are the clients walking? Why are they leaving? Why are they going somewhere else? This is why, okay? So this helps you understand the why. So I've got a bunch of notes down here about the variables, the reds and the blues, and the rights and the left. Blue, fewer meetings. Number of meetings since the last 90 days, AUM change. Red is positive, right? Complaints filed in the last 90 days, red goes over to the right, that's positive. Blue is negative, and advisor change the last 180 days, so that's 6 months. Again, red to the right and blue to the left. So let's go ahead and simulate more advisor meetings. Okay, so let's say hypothetically, if we engage with clients more, can we retain the clients? Can we keep them here because we're more active or more engaged with the client? Maybe we left the client alone and they're doing their own thing and we're doing our own thing, and the client is getting a little bit maybe antsy, anxious, whatever. I might leave because nobody's holding my hand. I'm not getting that white glove service. I might be ready to make a move somewhere else, right? So let's say, hypothetically, can we save the relationship? Can we keep the client here and keep this book of business, right? So the original churn probability was right here, 0.72. Again, I'm just looking at things over 0.7. So 70% chance of leaving. That's where I want to focus my efforts. If the guy is really happy or the girl is content or whatever, we have a great relationship and the churn probability is close to 0, I don't need to focus a lot of time and attention on these people. It's the people that are giving us their business right now that might take off in the next 6 months. That's where we have to focus the effort, right? So churn probability is 0.72. Churn probability after meeting should reduce the probability of churn. So this goes from 0.72 to 0.64. This guy's almost out the door. He's got 1 foot out the door, 99% to 97. This is 99, 98. This is 98. We took it down to, that one didn't change at all. And this is 99, 194, 99, 194. That didn't really change. But these at the top, we had and that's because they're sorting and descending order. So if you want to focus on the top 5 clients right here and reduce the probability of churn, these are the 5 people that I would call right now today. Reach out to these 5 people because they are 99% likely. Well, this one's 99%. These 4 are 99. This one's 72. These people are pretty much leaving the business and going to the competitor, right? But after engaging with the client, and we know what the top 5 are, right? We just have to find this client. It says 554. So we anonymize the information, or this is 554 record 554. We anonymize the information to make it anonymous because you don't necessarily want to have the client's name over here. Like if it's Bruce Springsteen or Bruce Willis. I don't know. I'm just making up some celebrity names. You don't necessarily want to have that in your data when you're doing your analysis. But if you have to call this person, you would map it back to this client ID to the actual client. So you have the phone number and the name of the person, things like this. And the same with the advisor identification, right? If the advisor ID is over here, you don't necessarily want to know who the advisor is as the data scientist or as the machine learning engineer. If you were the actual wealth manager, then I think it's totally fine to have the wealth manager name over there, right? And to have the client name over there. But as an analyst, you want to expose your clients to that. Not really. It's called PII, personally identifiable information. You don't really want to release that PII to an analyst or a data scientist or machine learning engineer. So we have sort of anonymous information, but whatever, right? You know what the top 5 clients are with the risk of leaving. These guys are pretty much gone. You can't save the relationship, okay? So we had like 360 rows or clients that had a greater than 70% chance of churn probability. We are going to reach out to these 5 right here first, and you can go down the list. You can get the top 10, the top 20, reach out, make a phone call, send a couple of emails, try to convert that potential churn event to a non-event, right? And keep the person with the firm, with the wealth management firm. These are the top 5 that you would reach out to. Now, in terms of grouping by advisor ID and churn probability, this advisor right here has the most clients that are about to leave. And this is number 2, number 3, number 4, number 5. So advisor A05, A01, 02, 03, 04. These 5 people probably have to be in a meeting with the CEO or like some C-suite executive, maybe head of HR, whatever you determine, set up a meeting with these 5 and say, hey, your book of business looks like it's ready to leave. Like, what's going on here? How can we help you? How can we help you to help your clients better? Because as an advisor, you are the top 5 advisors that have the most clients that are ready to leave. Like, reach out to the clients. We know the top 5 clients. We know the top 5 advisors that are at risk. We know the top 5 clients are at risk. How do we remediate this, right? How do we save these relationships? How do we keep the business, keep the books on the business? How can we do that? So let's go ahead and do a quick clustering exercise. Cluster right here, we're doing k-means, and we're setting the number of clusters to 4. I've got several videos on my channel about clustering, so you can learn all about that. So we've scaled the clusters, basically scaling is taking everything and normalizing it into the same relative form, right? So if you are comparing something that has high value to something that has low value, you're going to like train the machine to say, okay, high value is way better, low value is way worse, or something like that. You want to take everything, sort of normalize it and scale it so they're together. So if you're looking at a stock that costs $100,000 per share to buy, and you're looking at another stock that costs $10 per share to buy, it's hard to make a relative comparison between those two. But once you scale the data or standardize it or normalize it, then you can make those types of comparisons, right? So when you're looking at clustering or things like PCA, LDA, other machine learning techniques, you always want to scale the data before you go ahead and do the analysis, just to bring everything into the same kind of relative space, right? So if you have things that are extreme outliers and extreme anomalies and compare those to non-anomalies, that's going to be hard to do. If you scale everything, it's pretty easy to do. So we want to create an advisor dashboard right here so we know what the probabilities are. So you saw it above. So A5, 40% of the book is probably going to churn or leave. AL4 is 29%. So you see that over here, right? 29%, and there's 40%. So these are the 5 advisors we have to talk to and reach out to their clients too and say, hey, give us a second chance. We're here for you. How can we help you? How can we save this relationship? Things like that. So this is a correlation of feature with churn. So what is actually causing these people to leave? So leave the book of business. So we saw these events over here under the SHAP exercise, the churn probability, right? Obviously, these two are highly correlated, so we can kind of ignore this one right here. But based on login in the last 90 days, number of transactions, asset under management, response rate, so on and so forth, down the list, we know which features are causing people to leave. This is kind of a similar type of analysis, but slightly different. This is looking at the correlations between people leaving and again, the features that we had in the original feature set, number of emails sent, number of responses, asset under management, age of the client, things like that. So if there's any kind of correlation between a client leaving and the feature itself, we want to know about that as well. So this correlation analysis will help us understand that. Churn probability is over here. Of course, that's going to be high. We can kind of ignore these at this point. Complaints last 90 days. So if there's complaints, yeah, probably people are going to leave. They're going to complain about the business and they're going to take off. Advisor changed in the last 6 months. Yeah, that totally makes sense to me. Okay, we had a good advisor. He left. He went somewhere else or maybe retired. And maybe the client saying, hey, I don't like this new guy. I gave him 6 months. We're not really connecting. And I think I'm going somewhere else. Churn reduction, client segment, asset under management 90 days ago. So you can see the correlations on the right here of the median is positive correlation. So the more this happens, the more complaints, the more advisor changes, the more client segment, asset under management, the more these things happen, the higher the probability of churn. This actually has a negative correlation. So the age of the employee, the age of the client and the likelihood of churn actually has a slight negative correlation. And it's so small, it doesn't even matter. We can just ignore that. Asset under management change percentage. So this makes sense too, right? If the asset under management change increased, there'd be a churn event. If it decreased, that means it's not related to churn. Okay, there's no correlation between AUM, percentage change in churn, and same thing with number of meetings in the last 90 days. If you increase the number of meetings, are you increasing churn? No, you're decreasing it. If you have fewer meetings, fewer meetings, more churn, okay, because it's negative correlation, more meetings, less churn. So there's a negative correlation, okay? So I wanted to do one more test here. This is called an A/B test. So A/B testing is basically looking at a couple conditions where you have a control group and a treatment group, and you do a hypothetical scenario to understand the probability of the event occurring. Again, it's a churn event, so we're using the independent variables and the Y variables, right? So the independent is going to be dropping churn IDs, and the dependent variable is going to measure churn, just like we saw above with the XGBoost classifier. So these are the independent variables. This is the dependent variable, and we want to look at the statistical significance of this test. So we have the control group and the treatment group, okay, and measure both in a hypothetical scenario. If we, how does it work? Like if the treatment group where the client had more than 4 meetings is actually show a higher average prediction of churn, like 30%, 40%, 50%, than the control group, which is 34%. So a negative T statistic indicates that the treatment group churn is actually higher than the control group, okay? And this is the opposite of what you had hoped for. So here's the outcome. So the T statistic is negative 1.93. We need positive 1.96 or negative 1.96 to be statistically significant. So it's close, but it's not significant, right? So we can't say that this is a non-null hypothesis. This could be the null hypothesis. Null meaning nothing, so there's no statistical event, although it is close. And the p-value has to be less than 0.05. So again, pretty close. If you have a lower p, it'll have a lower t, or higher t. It's going to be more statistically significant. Both of these are right at the cutoff, but not over the cutoff. So there's no statistical event here. And the average predicted churn control, again, is 0.34%. So 34% are predicted to leave. And the average predicted treatment group is 0.3985. Okay, so there's really no statistical significance detected here. Although it's close, there's really no statistical event. So what does the A/B test do? It basically splits the group into 2 parts, the control group and the treatment group. A is the control group, B is the treatment or the variation group, and then you can measure how each group performs against the predefined goal or the metric that you have set up, right? So how does it work? Statistically, you start with a null hypothesis, which means no difference between A and B. The 2 groups are going to perform the same. And statistically, that's what we found here. There's really no difference between these 2 groups, right? So we run the test, we look at the conversion rates, then use the hypothesis training, the t-test, and the z-test to look for statistical correlations, right? To determine if there's an observed difference that is statistically significant. If it's significant, you can reject the null and conclude that this version is better, right? So the null would be the A group and B would be that there's actually a statistic event. But if you look closely, we kind of got different outcomes here, right? So here, statistically, we said, okay, there's a churn probability. We're going to ignore the churn because it's a high correlation between churn probability and churn. It's almost perfect, 100%. But if you look at complaints last 90 days, that should be an indicator of whether or not somebody is leaving, right? And we are measuring, we're measuring number of meetings in the last 90 days. So we see that over here. Where's the number of meetings? Okay, we see a negative correlation of 30%. So that's what we're measuring in an A/B test. And you can measure any of these variables. You can measure complaints in the last 90 days, advisor change in the last 180 days. We're looking at number of meetings in the last 90 days. And if this is less than 4, we're saying that is a significant event. So if you don't have enough meetings, the client is going to leave, right? That's the expectation. But here, there's no statistical significance between the number of meetings and the number of meetings less than 4 and number of clients churning. So you don't know if they're going to go or not with the A/B test. But with this analysis over here, the SHAP analysis, number of transactions, number of meetings, last 90 days. That's kind of small, I guess. Number of meetings in the last 90 days. That's kind of small. And we saw no statistical significance between the A/B tests. So they kind of align, right? But they're sort of giving us a little bit different messages too, because these are two different approaches to solving the same problem. So SHAP really looks at model feature importance. It measures associations and model predictions and learns patterns in historical data, doesn't control for co-founding, and says basically fewer meetings leads to higher predicted churn. That's what SHAP is telling us. When we look at the A/B test, this is a different perspective. We're looking at causal inference. So what causes something to happen? I have a couple of videos on my channel about this. There's a cause and effect, sometimes between variables, not all the time, but there could be a causal inference here. A/B test looks for cause of an impact or a treatment. Again, you have the control group and the treatment group. So one, you do nothing, and the other one, you do something to that. That's the control group. Compares randomized or quasi-randomized groups. Ideally controls for co-founding based on randomization events. And says additional meetings don't significantly reduce churn. Okay, so kind of different approaches to solving the problem, and we're getting kind of similar results. So I think that's pretty good in this case. But again, different approaches. And I think you should look at this thing from different perspectives and try to understand different approaches so you can make a more informed, more intelligent decision ultimately, right? So we know that more meetings doesn't necessarily reduce churn. If you have no meetings, the people might walk. If you have too many meetings, they might get upset and might leave. But there's no statistical significance between 4 meetings or less and people leaving the wealth management firm. That's proof conclusively, right? So SHAP does not equal causality. Just because the model is using number of meetings the last 90 days to predict churn doesn't mean adding more meetings will prevent churn. Okay, so save the advisor's time. You should have around 4 meetings. Don't have more than that. You're wasting advisor time, you're wasting the client time. If you have 10 meetings, that's a huge waste of time. And people might leave anyways because it's like, hey, I'm coming in for too many meetings. You guys should be busy making me money on the portfolio and not setting up so many meetings, okay? So the model can be picking up correlated behaviors. Clients who stop taking meetings may have already decided to leave. They've made up a decision in their mind they're going to leave anyways. So saying that more meetings isn't going to save the relationship. They're gone. They're walking. Okay. That's it, guys. I'm going to wrap it up here. Hopefully that was informative and inspirational and motivational and all those other great, wonderful things. I'm going to save a copy of this code so you can take it and run it in your own environment. Again, substitute my data frame for your data frame. All you have to do is plug in your data frame. You can do the same analysis, make a couple of little tweaks here and there, and you're going to be able to answer these questions about A/B testing, about SHAP analysis, about XGBoost classifiers, and all these fun, wonderful, lovely types of analysis that we can do. Okay, so I'm going to wrap it up here. I will post the video a little bit later today. I'll post all the codes so you have that. Copy paste it again, run it in your environment, and you're good to go. I'm gonna sign off now, and I will see you guys shortly when I post the next video. Goodbye for now.